Good afternoon. Today I'm going to present our work about how to use intelligent user interface to help data security analysts to fight against data breaches. The title of our paper is What Data Should I Protect? Recommender and Planning Support for Data Security Analysts. I'm Tianyi. This work is done with Dr. Gregorio Convertino and our ex-colleagues Ranjeet and Shima. So recently there are increasing number of data breaches, the amount of users being affected, and the companies are suffering from a lot of losses. And if you know GDPR policy, if you lose the data of citizens from the European Union, the company might suffer from as much as 4% of their annual turnover as a penalty. Taking the 2017 Equifax data breach as an example, 143 million users were affected. The US Congress committee called this breach completely preventable, and the United Kingdom also fined them. Why can't the companies stop them? Why the data breaches continue to happen? Well, the traditional reactive data security solutions, such as firewalls, antivirus softwares, they sometimes are not fast enough to update, at least not as fast as the hacking technologies. And also the monitoring softwares, they detect what is attacked and where, but sometimes it could take 6 months for the companies to detect a data breach. Not to mention they also need to isolate and remediate the infections. So recently there is a new domain called proactive data protection at source. It relies on data security analysts to read the flagged risk of their data properties, decide what to protect and how proactively. The challenges are now how do the data security analysts develop a mental model of the complicated risk information to overcome the information overload, as well as make a protection decisions to consider multiple factors such as the protection goals and the available resources they have in the organization. So in this paper, we focus on solving the problem of designing intelligent UI to assist data security analysts to address those two challenges. How do we overcome the information overload from the complicated risk information, the large amount of data? And how do we do multi-factor prioritization to achieve the protection goal with the available resources in the organization? However, it is not easy to design for data security systems. By definition, the users, their practices, and the data we want to protect are confidential. And because proactive data security is a new domain, there's no successful system for us to reference. Also, the data managed by organizations are different. Healthcare, finance, they need different solutions. And as with all the data, software development in industry, the long production cycle makes it very difficult to include real users in our iterative design process. So in this work, we adopt user-centered design to address these challenges. We started with a focused user research with 11 users from 11 companies. And because it is difficult to get real users, it took us 1 year to get their consent and schedule their interviews. After that, we built on the findings and conducted 4 iterative design and evaluation cycles with 10 participants. And here we used proxy users. They are product managers and sales engineers who have dealt with real-world users every day and observed their needs and requirements. So they can serve as a proxy in our iterative design process. So here's what we did. In the user research, we collected user practices, their pain points and requirements. On top of the findings, we proposed a problem modeling and validated it in our design workshop. After that, we developed a low-fidelity prototype to validate our design concepts and workflows. And based on the feedback we got in the evaluation, we developed our first iterative prototype to evaluate the interaction design. And finally, we develop our final system and evaluate in the last cycle. Now I'm going to first report the major findings in our user research. So we define our user persona as professional security analysts who who make investment decisions for data protection, proportionate to the risk mitigation and the lifetime of a data set with a given budget. That is to decide what data needs protection and whether it's worth the protection. We also find out there are a lot of unsatisfied needs in current data security analyst practices, such as disconnected tools, lack of intelligence. And here we also list some top analysis tasks, such as defining security strategies for the company, set rules to monitor the data security, as well as reviewing and analyzing the compliance level of the government policies. So let's take a step back and ask the question, what data is at risk and why do we need to protect them? Assuming we have a user, Amanda, we have a social security number. That's a personal identifier's information that requires top-level security. Her first name is just a personal identifiable information. It's not as important as SSN number. But when the first name appear together with an address, it becomes personal identifier and requires higher level of security. The data is stored in different data stores on the different servers, locations, and the companies and organizations also have users who have different access to the data, and they have actual footprints, whether they have accessed the data when and how. So the data have a lot of attributes. Let's put some order in it. In this paper, we propose this separation of concerns that the data has architectural risks in terms of how it's being stored in the databases and how it's being managed. It also has conceptual risks in terms of how the data is used, what data means to us. We introduce a structure to compute our risk quantification. By categorizing the risk attributes, we have the risk factors, and we compute the risk scores of the two concerns. This helps us explain the risk of quantification with our explainable UI. And now I'm going to do a live demo of our final system. It's composed of a recommender sidebar, plan building workspace, and based on our evaluation cycle, we also had a new low fidelity prototype of the plan review and comparison prototype. So we built our prototype on top of an proactive data security system that flags the risks in the organization. It's called Informatica Secure and Source. The user can click on Protect Data and see the recommendations. The recommendations are grouped by the data attributes we mentioned earlier. And they can also see the current risk metric values on the top carousel bar. The recommendations are ranked by different risk metrics. So if I care more about data risk cost, I can see the GDPR policy and all the data stores governed by it contributes a lot to the data risk cost. When I click on a recommendation, I can see the details of the data stores in this group, and the data stores are also ranked by the data risk cost. By clicking on the recommendation, I can see the expected future values of the risk metrics on the top. And here we also can see the estimated protection expense as well. And if you see the upper right corner here, we show there are 5 stores automatically put in the protection plane already. If you click on this plan link, you're automatically transited into this plan building workspace. Here we can see the details of each data stores included in the recommendation. And on the right, we saw the residual value of the risk metrics. That is, if you assume the data store was protected, these are the future value of the data risk metrics. For example, here, if we care a lot about risk metric, data risk cost, we need to protect this Oracle data store to achieve the most impact. Whereas if we care more about risk score, we need to protect this Hive data store. And at the same time, we can also see the remaining risks metrics and their future values as well. And we can always go back to the recommender sidebar through the plan building workspace to include more recommended groups of data stores, and will automatically be integrated in the plan building workspace. So as we mentioned earlier, we had 11 real users in our user research. We have additional 10 participants in our 4 iterative design process. And here you can see how which participant participated in which iteration. And you can see their job roles on the very first column as well. Next, I'm going to present the final evaluation result in the last column. There are 5 participants. We also followed semi-structured interview as with previous cycles. We spent the first 40 minutes to evaluate the interactive prototype as we demoed earlier, and then the next 20 minutes on the low-fidelity prototype about the plan review and compare prototype. So overall, we received pretty positive feedback. The recommender sidebar was considered very helpful in reducing the information overload. All 5 of the participants found it first very easy to understand, and also it is useful to navigate through the risk information and get familiarized with what data I need to protect. And number 2 is they applauded the iterative plan building. That is, we can go from the recommender sidebar to the plan building workspace and then go back to iterate on the plan building. Participant 9 not only tried different rankings, she also reopened the sidebar to add more data stores in the evaluation session. And participant 10 was just very amazed that, oh, I can go back and forth. And the participants also like our impact analysis very much. So by showing the current value and predicted estimated future value of the risk metrics, they can estimate the potential impact of protecting different data stores. This helps them understand the overall risk, and it's helpful for them to report and justify whether a data store is how a data store worth this much of budget to protect it. And the low fidelity prototype was also considered useful to compare the different protection targets and alternative plans. And what is also interesting is our interface triggered more requirements to support their other analysis tasks. So participant 9 and 10, they suggested there are other ways. In addition to the data security policies, we can also introduce lines of business locations to aggregate the risk information. And also the plan comparison and reviewing interface is very useful that participant 4 mentioned. His team created about 12 plans every year, and about 20 or 25% got approved for implementation. So yeah, in this paper, we present intelligent user interface for data security analytics and analysts that design separate the concerns of what data we should protect and how, and we support iteration through the 2 subtasks. To address the domain-specific challenges, we adopt user-centered design with 1 focused user research followed by 4 iterative design and evaluation process. We also rely on both real users and proxy users to open up the user pool and accelerate our work process. And also about the next step in generalizability, there of course requires more evaluation work in different conditions and use cases. Also, more work will need to be done to improve the risk measurement and prediction. This is actually a continuing effort that the entire domain is working on. Also, for other domains such as healthcare and finance that share similar data security domain-specific challenges, they could also adopt similar approach with user-centered design to address the similar challenges. Thank you. I will be happy to take questions.
Questions? Okay, so I've got one question. Mm-hmm. And you presented, if I recall correctly, the risk analysis is based on costs, risks that are costs.
Right.
Seems like a monetary risk. And I was wondering whether this is the only measure, this is the only thing that should be considered, because there are risks that may not be measured by costs, but risks to individuals, to privacy. I don't know how you can have any cost associated with them?
Right. So in this work, we follow the original risk metrics in the existing system, secret source. So we have risk score, we have data risk cost, and protection percentage. So these are far from enough, of course, but it's a continuing effort for us to improve our risk measurement. Like you said, it's difficult to quantify how much reputation damage, for example, is gonna lead to if we didn't protect this data store. So at this moment, we only quantify the cost by dollar value. For example, if the data policy regulates we need to give the company a certain amount of fine, and we compute how much money you need to pay per each row. So that's a pretty naive way of doing it, but it's a start.
Hi, very interesting talk. I was wondering, so also related to the cost to a certain extent, I imagine if you have certain data in multiple databases, which unfortunately still happens, if you protect one but leave the other one unprotected, then you're not really solving anything, right? Because so I wonder how do you deal with those dependencies, so to say, between like different data types? You need multiple protections in order to actually protect something.
If I understand you right, you're talking about data lineage, that the data store copies data from another data store, and the data is also copied to some external resources. Right, so yeah, we rely on the underlying system to flag all those risk information. And here, for example, in this screenshot, if we protect the visitor's policy and all the underlying data store, we assume the data stores are already marked as being governed by those policies. But I agree that's a problem that we need to be very careful about.
Okay, so let's thank our speaker again.